Hi, in this video we're going to see how we can sketch quartic graphs. Now, just to remind ourselves, when you have a factor like this, like a bracketed factor of like x minus a, then you get a cross at a0, so on the x-axis. If you have the bracket squared, so it's a repeated factor, you get a touch at a0, and then if it's cubed, then you get a point of inflection. We'll see that in a moment. At a0. Yep. So let me just highlight that. So point of inflection versus touch versus cross. Also note that with cubics, if it was a cubic, for example, then a positive cubic, if you have a positive x cubed term, like 1x cubed, for example, is going to have an uphill trajectory. And if you have a y equals minus x cubed or something, it's going to be overall a downhill trajectory. Now, this is a quartic, and a quartic is basically where you have an x to the 4 term, because if I expand this out, you get x times x times x times x, which will be x to the 4. Now, if you remind ourselves how quadratics work, if you have a y equals positive x squared plus some other stuff, then we know it has the tails going up like that. Whereas you have y equals minus x squared with some other stuff, it's going to be a sort of frowny face with the tails going down like that. And it's very similar with x to the 4 quartics. So if you have a positive quartic, it's basically going to be like that. So the arms are up, just like with a positive quadratic. And if you have a negative quartic like this, then the tail is going to go down at the end, just like with a negative quadratic. So it's going to be tails going down. But basically, if you compare these different graphs here, the number of turns in the graph is one less than the maximum power. So for example, we've got x squared, the maximum power is 2. If you take one away from that, you get 1. It's saying it has one turn. It turns once. This turns once. A cubic, it's got the highest power is 3. So take away 1, you get 2. So it's going to have 2 turns. Look, 1 turn, 2 turns, 2 swerves. And quartics, take away 1 away from 4, it has 3 turns. So 1 turn, turn, turn. There's 3 turns, right? So we know that the shape is going to be something like this. So with this one, sketch a graph of this. I'm going to do it up here because I've run out of space. If I do my axis, and then we've got roots of, if you make each of these things 0 to get, because y is 0 on the x-axis. So if y is 0, if x minus 1 is 0, then you get a root of 1. We're also going to get a root of minus 5 because x was 5 is 0. You're going to get minus 5. I'm not using the grid lines on here. Then we get a root of 3 and we get a root of minus 2. So these are different roots. As we said, if we're not repeating the factor, because none of these are repeated, none of them has a squared on it, you get a cross at the root. So also note that because it's a positive quartic, because you get positive x to the 4 in expansion, the tail is going to go up. So the tail is going to go up and you're going to cross at each of these. So you're going to get something like that, right? We should also put in the y-intercept. And to get this y-intercept, we're just going to make the x value 0. So if x is 0, we're going to get minus 1 times 5 times minus 3 times 2. So that's positive 30 and we are done. What about this one? Well, let's see. We've got... we're going to sketch it. We have roots of, Now, if we look at the roots, our roots are going to be minus 3. If we make the x was 3, 0, and the other root is going to be positive 4. So let's put these on the graph. We're going to have minus 3 and 4. Now, this factor is not repeated, so it's just going to cross at minus 3. But this is triple repeated. It's x minus 4 cubed, And we said that we get a point of inflection. And I'll show you what that looks like. Also note that this is x times x times x times x. It's going to be positive x to the 4, so the tail is going to go up. So as we said, the graph is going to cross at the -3. And then what's going to happen at this 4? So at the 4, we get a point of inflection. And what the point of inflection looks like is it kind of plateaus. So the graph becomes momentarily horizontal, and then it's going to go back up like that. So this is the shape we're going to get. Now we need this y-intercept again. That's where x is 0. So if we sub in 0 into this, we're going to have 0 plus 3 is 3 times -4 times -4 times -4. So that's going to be negative 192. I hope I've got that right. I don't have a calculator on me. So that, I think, is the final graph. We've got another one here. So we've got the x is squared and the x plus 5 is squared. If we draw it, now, this is a positive quartic because you've got x squared times x squared in expansion, positive x to the 4, so the tails are up. And our roots are going to be at, well, this is going to give you a root of 0. That's one root. And then this is going to give you a root of -5, which is here. And because these are repeated factors, as x squared, x plus 5 squared, the graph is going to touch at these. So it's going to touch at the -5. And it's going to touch at the 0 like that. Sorry, that's a bit wonky. Let's do that again. That's better. So you're going to get something like that. And this last one, this is going to be a negative quartic. So we're going to get roots of 0, 4, and -5. But also note that this is a negative quartic, because if you to expand it, you're going to get -x times x times x times x, which is -x to the 4. So the tail is going to go down. So let's put the roots on here. We have roots of 0, 4, and -5. And so, as I said, the tails are going down, so it's coming up like this. Now, because this is x plus 5 squared, we're going to get a touch at the -5. So it touches at the -5, comes down, and then these other ones are not repeated, so it's going to cross at the 0 and it's going to cross at the 4. So it's going to cross at the 0 and it's going to cross at the 4 like that. And that's the final graph with that one. Now this final quartic one, I've kind of got to add an extra row here because I didn't cover the cases where you have like x minus a to the 4. And basically this one is unfortunately quite unexciting. If it's a quadruple repeated factor, so x minus 1 to the power of 4, what ends up happening is it just looks the same as a touch. So this gives you basically a touch point. So if I draw this, we have the root at 1, and then it's a positive quartic because if you expand it, you get x to the 4. So you're going to basically just get a touch at the 1. So it resembles a quadratic. It looks a bit like a quadratic, to be honest. We need the y-intercept. When x is 0, y would be 0 minus 1 to the power of 4, which is just going to be 1. And that will be your graph. The reason it's just a touch is because if it's if you've got the root of 1 4 times, basically, it's a quadruple repeated 1, like the roots are 1, 1, 1, and 1. They just all happen to be the same. Basically, what the graph does is it crosses at 1, crosses at 1 again, crosses at 1 again, and crosses at 1 again, because each time you have the root, it kind of crosses the graph. And because they're all the same value, it crosses at 1, 1, 1, and 1, they basically are merged all together, and it just basically just becomes a touch.